Okay, now we want to do pressure calculations based on what we've learned about the different pressure measurements. We have a couple objectives here. One is to explain the different ways that pressure can be measured and to be able to convert that pressure into different forms of measurement. So we have the two different measurement systems. We have the imperial-based system. A lot of people call that the English-based because it was based out of England. The imperial system is what we're most used to in the United States. We are down to 3 countries that are the only countries that use this system. The United States is one, Liberia and Myanmar are the only other 2. Everyone else is on System International, which most people know as the metric system. So the imperial system, the measurement for length is foot, the measurement for weight is pound, measurement for temperature is Fahrenheit, and for volume it's gallons. In the metric system or System International, the distance measurement is based on the meter, the weight is based on the gram, temperature is based on the Celsius, and volume is based on the liter. Since in the United States we are still primarily using the imperial system, I'm going to focus on that for the remainder of this presentation, and basically for the remainder of the semester we will still be working on the imperial system. Okay, so one of the forms of pressure measurement is hydrostatic pressure. And hydrostatic pressure is nothing more than pressure exerted by a column of liquid. So in the picture here, I'm showing a column of water, but it doesn't necessarily have to be water. It could be other forms of liquid. The 2 most common forms that we use in the control system business is inches of water. Some people call it inches of water column, which is a way of just describing what's happening, and an inches of mercury. So for inches of water, 27.7 inches of water column equals 1 pound per square inch. Now in my depiction there, I'm showing 27.7 inches high, and the area of that column is 1 square inch. But the height actually is not, the volume is not important because it's only the height. And of course, we're measuring on pounds per square inch. Another form of measurement is using inches of mercury. So inches of mercury is 13.6 times more dense than water. So therefore, if you take 27.7 and you divide it by 13.6, you're going to get 2.04, which is the amount of mercury column that you would need to produce 1 pound per square inch as well. Okay, so there again, although the scales of the drawings are not the same, the area of the base of that column is a cubic or square inch, and so if you have a height of 2.04 inches of mercury, you're going to be experiencing 1 pound of pressure. Okay, when we talk about hydrostatic pressure is one form of measurement. Another form is how we are going to read this and measure it based on atmospheric pressure. So absolute pressure is based on atmospheric pressure. So it accounts for atmospheric pressure. It has the same units whether under pressure or in a vacuum. So it has a benefit there, and we're going to see that when we look at the next slide. But it is less commonly used in the field. What is more commonly used in the field is gauge pressure. Gauge pressure does not account for atmospheric pressure. So gauge pressure, if I have a gauge and it's not hooked up to anything, it's going to be reading 0. It has different units, whether we're under pressure or under vacuum. We're going to see that here in a minute. But it is the most prevalent form of pressure measurement that we have in the field. Okay, so on the left, I'm showing an absolute pressure gauge held just in atmosphere with nothing acting upon it. And it's going to measure, at least if we're at sea level, or basically at sea level, 14.7 psia. Okay, So that's measuring the pressure around us at sea level. Gauge pressure at the exact same location, the exact same thing happening, is going to read 0, okay? Because it is not trying to measure atmospheric pressure at all. It's trying to measure the pressure above atmospheric pressure. So here's an example. If I add roughly 15 pounds per square inch to each gauge, I am going to wind up with 30 psia on the absolute gauge, because if you take the 15.3 pounds per square inch added to the absolute gauge plus the atmospheric pressure of 14.7, you're going to wind up with 30. On a gauge, PSI G, gauge pressure, gauge, you are going to just read 15.3. You're going to read the amount that is above the atmospheric pressure. Here is a chart that's going to compare the two for us. You see in the middle, in the kind of white area, this is atmospheric pressure, at least atmospheric pressure at sea level. Of course, if you leave sea level or if there's a barometer change, that is going to be affected. But for demonstration purposes, we're going to assume sea level here. And 14.7 psi on the absolute scale is going to be 0 psi G on the gauge scale. Okay. Now, as we increase, it's linear. So I increased 5 psi. I went to 19.7 psia, and I went from 0 to 5 psi G. Okay. So it's not different scales. It's just different reference points of where you started. Okay. Again, I changed only 5 psi here to go to 24.7, or I'm 10 psi G on the gauge side. Now, the example that I showed in the previous slide where it showed 30 psia is 15.3 psi G. You can see it here on the scale as well. Now, I show a kind of a hash mark here because this scale continues on in the positive direction. If we go in the negative direction from atmospheric pressure, that is, we are entering into a vacuum. A vacuum is, pressure is when we add molecules into a volume and increase the pressure. A vacuum is when we remove molecules from a vessel and we create what could be considered negative pressure, or in the case of our measurement, a vacuum. So for PSIA, the units don't change because we are reading 14.7. As we go down closer to a perfect vacuum exists when you have removed all of the contents of a vessel and just the vessel walls itself remain, and it has an absence of any material on the inside. That is what's called a perfect vacuum. And if you were reading it with an absolute gauge, you would read 0 psia. If you were reading it with a gauge measurement, we change units. The units go to inches of mercury. And this is very commonly used in the refrigeration industry for pulling a vacuum on a system. But as we go below 0, we're going to start to measure in inches of mercury. And a perfect vacuum technically is 29.92 inches of mercury. But for all intents and purposes, gauges are marked 0 to 30 inches of mercury, just for a reference point. So as we go negative here, now notice the number is not negative. When we talk about inches of mercury, we're still going to talk about a positive number, but it is going to be referencing a vacuum. So a vacuum is going in the opposite direction, but so this is inches of mercury vacuum is the proper way to denote that. Differential pressure. Differential pressure means that the difference between the two measurements is going to be not necessarily referencing either PSI-A or PSI-G. The difference is just going to be in pounds per square inch. Because you can see here from 15 PSI to 5 PSI, I have moved PSI-G, I have moved 10 PSI, pounds per square inch. From 29.7 to 19.7, again, I have moved 10 pounds per square inch. So when we talk about differential pressure, it is no longer PSI-A or PSI-G, as long as when you're doing the math or you're doing the measurement, you're using the same units on both the high and the low side. Okay, now let's do some examples of converting from one form of pressure measurement to another form of pressure measurement. The first one we have here is we want to take gauge pressure and convert it to absolute pressure. So our sample is taking 12.3 pounds per square inch gauge and converting that to absolute pressure. So we're going to use this formula. Pounds per square inch absolute equals pounds per square inch gauge plus 14.7 pounds per square inch absolute, which is our pressure, atmospheric pressure at sea level. So our pounds per square inch absolute is going to equal my 12.3 gauge pressure plus my 14.7 atmospheric pressure to give me 27 pounds per square inch absolute. Okay, let's look at taking absolute pressure and converting it back to gauge pressure. So now in our example, we want to convert 15 pounds per square inch absolute to gauge pressure. So our formula is a little different. We just transposed it from the previous slide, but pounds per square inch gauge equals pounds per square inch absolute minus that atmospheric pressure. So pounds per square inch gauge will equal the given 15 psi-A minus my atmospheric pressure at sea level, and that will give me 0.3 psi gauge or psi-G. Okay, so now let's take pounds per square inch absolute and convert it to mercury vacuum pressure. So we want to convert 5 psi-A. So note that if we're in that range, we're in a vacuum, because anything less than 14.7 pounds per square inch absolute, we are in a vacuum situation, which I have a graphic here. So here's our atmospheric pressure at 14.7 psi-A at sea level. If we go above that, we're in the pressure range, but if we go below that, we're in a vacuum. So what we're trying to do here is find out where we are on the gauge pressure scale versus the absolute pressure scale. And so we have a couple unique steps that we have to do here. Number one, we need to figure out how far away we are from 14.7. Notice I have one scale that is increasing in value as I increase into the vacuum realm, where the other scale is decreasing in value as I increase my vacuum magnitude. So what we need to do is find out how far into the vacuum range we have moved on the PSI-A or the absolute scale side. So we take 14.7 and we subtract our given absolute pressure reading to get how far we've moved into that vacuum range. So we're trying to figure out this distance from here to here is what we're actually trying to figure out. So if we subtract that, we get 9.7 psi-A vacuum. So that means I've moved 9.7 psi-A units from my 14.7. So I've traveled that magnitude, that distance. Okay. Now I can convert that because I have a direct conversion from that over to my inches of mercury using this formula. So I'm just going to take that absolute vacuum reading and I'm going to multiply it times my conversion from pounds per square inch to inches of mercury. So I'm going to take my 9.7 psi-A times my 2.04 inches of mercury, and that gives me 19.08 inches of mercury. And if you look on the graph here, that kind of makes sense. I'm right here at 5 pounds per square inch absolute. If you come across, I am not quite to 20 inches of mercury. So that looks appropriate, the answer. Okay, now let's take water column and convert that to gauge pressure. If I have 52.5 inches of water, I want to convert that to gauge pressure. And so we just use this simple formula. That's going to take 1 psig is going to equal 27.7 inches of water column. So all we have to do is take that inches of water column and divide it by that 27.7, and that's going to give me my gauge pressure. So if I take my 52.5 and divide it by 27.7, I wind up with 1.9 pounds per square inch gauge, or psig. Now let's take water column, convert it back to absolute pressure this time. So we're going to do this by going through gauge pressure. So we want to convert 61.1 inches of water to absolute pressure. First, we're going to convert that to gauge pressure and then convert gauge to absolute pressure. So again, our formula for 1 psig is 27.7 inches of water. And so we're going to get this to gauge first by just taking our given of 61.1, dividing it by our 27.7 inches of water, and we get 2.2 pounds per square inch gauge. But we're not done yet because we want absolute pressure. We don't want gauge pressure. So we're going to use this formula. To get our absolute pressure, we have to take our gauge pressure and we need to add in our atmospheric pressure. And again, that's atmospheric pressure at sea level. So pounds per square inch absolute takes into account 2.2 pounds per square inch gauge plus 14.7 pounds per square inch absolute, and we get 16.9 pounds per square inch absolute. So 61.1 inches of water column equals 16.9 pounds per square inch absolute. Okay, so now let's take inches of mercury, and we're going to go to feet of water column in this example. Okay, so this is not going to be inches of water column. We have to do another conversion to get it to feet of water column. So we have 52.02 inches of mercury, and we want to convert that to feet of water. Okay, so we're going to go again through pressure, then to inches of water, then to feet of water. Okay, so first, to get to our pressure, gauge pressure, we are going to take the 52.02 inches of mercury and we are going to divide it by the 2.04 conversion units, and we're going to get to 25.5 pounds per square inch gauge. Okay, so now we want to take that gauge pressure and we want to convert it to inches of water column, because that's a formula that we know, and that's that formula right there. 1 pound per square inch gauge equals 27.7 inches of water column. So we just take our 25.5 pounds per square inch gauge times our 27.7 inches of water column. We get 706.35 inches of water column. Okay. Now, to go from inches of water to feet of water, the formula is very simple. You just divide by 12 because there's 12 inches in a foot. And so when you do the math and divide our product by 12, we're going to get 58.86 feet of water. So 52.02 inches of mercury equals 58.86 feet of water. Okay. Now, in doing all these conversions, there are numbers to remember. And I just remember these three. 14.7 psia is your atmospheric pressure. Of course, that is at sea level. Okay, if we raise in elevation, our atmospheric pressure is going to decrease, but all of our conversions that we're going to be doing is going to be assuming sea level. 27.7 inches of water column is going to equal 1 pound per square inch gauge, and 2.04 inches of mercury is also going to equal pounds per square inch gauge. If you can remember those three numbers, and you can be able to convert all of the different scenarios you're going to be given on the practice sheet and the test. So that is to prepare you for doing your practice sheet, your study guide, your quiz, and your test for the pressure measurement unit. I hope that helps, and we'll see you in the next video.